Welcome to Department of Collegiate and Technical Education. This is a video series on course Water Supply Engineering for 3rd semester Diploma Civil Engineering. This is session number 16, Quality of Water. The course outcome is to ascertain the quality of water as per Bureau of Indian Standards. In the previous sessions, you have learnt about the water requirements of the town, sources of the water, intake and conveyance of water. For designing a water supply scheme for a project, several factors has to be considered. Any project is to be designed for an anticipated population in the design period. The future population is considered for the design and the anticipated population is calculated by several methods. The rate of the demand of water is calculated by considering the various demands of the water such as domestic, institutional demands, commercial demands, etc. The quantity is worked out by considering the population and the demand of the town. Similarly, sources of water requires several factors to be investigated. Quantity of water should be sufficiently available to meet the demands of the town, as well as the quality should be good and it should not contain harmful substances that may cause potential danger to the public health. The water should be treatable. Any water has several constituents such as minerals which are required for the humans. So all the impurities need not be treated. Some harmful substances are to be treated. So you have also studied about intake and conveyance of the water. So in this session we will study about the impurities in water, analysis of the water, physical examination of the water. So quality of water. Quality of water is analyzing the characteristics of water to suit for a particular purpose. So what are the characteristics of the water? That is physical characteristics, that may be temperature, color, odor, etc. Chemical characteristics, chemical parameters such as chlorides, hardness, etc. And bacteriological characteristics of water are studied to meet the to check the safety, to check the supply of water to the public. The impurities in water are to be removed to a certain extent so that it does not prove harmful to the public health. Poor water quality pose a health risk for the people. So let us discuss some terminologies. So potable water. Potable water is the water that is safe to drink or to prepare for food and it is pleasant to taste. Potable water is the water that is fit for the domestic purpose and it has a pleasant taste. Wholesome water is the water that is fit for drinking, cooking, food preparation, washing, etc. and it should not contain any harmful ingredients that may potential danger to the human health. That is called a wholesome water. Polluted water. You might have heard the word pollution. Polluted water is the water that contains undesirable substances in the water and makes it not fit for drinking and domestic use. So polluted water contains some harmful or undesirable substances that make it not fit for the drinking and the domestic use. Contaminated water. Contaminated water is the water containing disease-causing bacteria which is not fit for use. So they contain the disease-causing bacteria and it is not fit for the consumption or any other purpose. That is called contaminated water. So let us study the hydrological cycle of water to know the stages of impurities that may enter into the water. So hydrological cycle, if you observe the hydrological cycle of water, all the evaporated water from the surface of the water enters into the atmosphere and they are condensed at the clouds. The evaporated water are condensed in the clouds in the form of the droplets. When these droplets combine together and become heavy, and they precipitate on the ground. So this precipitated water moves from higher areas to lower areas and becomes surface runoff. So this surface runoff, if there is an obstruction, forms, if there are ditches or some it becomes ponds, and if it flows to become the rivers, then it finally reaches the sea. So this is the hydrological cycle of the water. So ನೀರು ಆವಿಯಾಗಿ ಅದು ಮೋಡ ಸೇರುತ್ತೆ, ಆ ಮೋಡದಲ್ಲಿ ಡ್ರಾಪ್ಗಳಾಗ್ಬಿಟ್ಟು ಕಲೆಕ್ಟ್ ಆಗುತ್ತೆ. ಅದು ಎಲ್ಲ ಡ್ರಾಪ್ಗಳು ಸೇರ್ಕೊಂಡು ಭಾರವಾದಾಗ ಮಳೆಯ ರೀತಿಯಲ್ಲಿ ಭೂಮಿ ಮೇಲೆ ಬರುತ್ತೆ. ಭೂಮಿ ಮೇಲೆ ಬಂದ್ಬಿಟ್ಟು ಎತ್ತರದ ಪ್ರದೇಶದಿಂದ ತಗ್ಗು ಪ್ರದೇಶಕ್ಕೆ ಹರಿದುಕೊಂಡು ಹೋಗುತ್ತೆ. ಹರಿದುಕೊಂಡು ಹೋಗಿ ನದಿಗಳನ್ನ ಸೇರುತ್ತೆ. ಅದೇ ರೀತಿ ಹಳ್ಳ ಗುಂಡಿಗಳು ಇದ್ದಾಗ ಅಲ್ಲಿ ಪಾಂಡ್ಸ್ ಮತ್ತು ಲೇಕ್ಸ್ಗಳು ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಕೊನೆಗೆ ಈ ನೀರು ಭೂಮಿಯೊಳಗೆ ಸೀಪೇಜ್ ಆಗಿ ಗ್ರೌಂಡ್ ವಾಟರ್ನ ಸೇರಿಕೊಳ್ಳುತ್ತೆ. ಅದೇ ರೀತಿ ಕೊನೆಗೆ ಮುಂದೆ ಸಮುದ್ರವನ್ನು ಸೇರುತ್ತೆ. ಇದು hydrological cycle of the water. So at various stages, let us see what are the sources of impurities. Rain or precipitation at its formation contains no impurities and pure in its nature. ಮಳೆ ನೀರು ಮೋಡದಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆದಾಗ ಅದು ತನ್ನ ಪ್ಯೂರ್ ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ. ಅದರಲ್ಲಿ ಯಾವುದೇ ಥರದ ಇಂಪ್ಯೂರಿಟೀಸ್ಗಳು ಅಲ್ಲಿ ಇರೋದಿಲ್ಲ. ಆದರೆ when this rainwater enters the atmosphere, it absorbs various gases and other substances. Water is called the universal solvent. It absorbs many impurities. Hence, so when the rainwater enters the atmosphere, it absorbs various gases in the atmosphere, that is carbon dioxide, oxygen, nitrogen, etc. These are the gases in the atmosphere, and these gases are absorbed by the rainwater during its journey from the clouds to the atmosphere. ವಾತಾವರಣಕ್ಕೆ ಬಂದಾಗ ಮಳೆಯಿಂದ, ಸೊ ಇದು ಕ್ಲೌಡ್ಸ್ಗಳಿಂದ ವಾತಾವರಣಕ್ಕೆ ಬಂದಾಗ ಅಲ್ಲಿರುವಂಥ ಅನಿಲಗಳನ್ನು ಅದು ಅಬ್ಸರ್ವ್ ಮಾಡುತ್ತೆ, ಹೀರ್ಕೊಳ್ಳುತ್ತೆ. ಆಸ್ ಇಟ್ ಫ್ಲೋಸ್ ಆನ್ ದ ಅರ್ತ್ ಸರ್ಫೇಸ್ ಆಸ್ ಸರ್ಫೇಸ್ ರನ್ ಆಫ್, ಇಟ್ ಕ್ಯಾರೀಸ್ ವಿತ್ ಇಟ್ ಸ್ಯಾಂಡ್, ಕ್ಲೇ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಕ್ಸೆಟ್ರಾ. ಸೊ ವೆನ್ ದಿಸ್ ವಾಟರ್ ಎಂಟರ್ಸ್ ದ ಅರ್ತ್ ಸರ್ಫೇಸ್, ಇಟ್ ಫ್ಲೋಸ್ ಫ್ರಮ್ ಹೈಯರ್ ಏರಿಯಾಸ್ ಟು ಲೋಯರ್ ಏರಿಯಾಸ್, and during its journey it picks up sand, clay particles, etc. So muddy particles are picked up by the surface runoff, and thus clay, silt and the other particles enter into the water. So ಇದು ಭೂಮಿ ಮೇಲೆ ಬಿದ್ದಾಗ ಭೂಮಿನಲ್ಲಿರುವಂಥ ಮಣ್ಣು ಪದಾರ್ಥಗಳು, ಸ್ಯಾಂಡ್ ಮರಳಿನ ಪದಾರ್ಥಗಳು, ಮತ್ತು ಕ್ಲೇ ಅಂದರೆ ಜೇಡಿ ಮಣ್ಣು, ಈ ಥರ ಮಣ್ಣಿನ ಪದಾರ್ಥಗಳನ್ನು ಅದು ನೀರು ತನ್ನ ಜೊತೆ ಕೊಚ್ಚಿಕೊಂಡು ಅದ್ರ ಜೊತೆ ತಗೊಂಡು ಹೋಗುತ್ತೆ. ಸೊ rivers or streams are contaminated by wastewater from the industries, sewage disposal, garbage and harmful bacteria. ಸೊ ಮಳೆ ನೀರು ಕೊನೆಗೆ ನದಿ ಸೇರಿದಾಗ ನದಿನಲ್ಲಿ ವೇಸ್ಟ್ ವಾಟರ್ನ ಮತ್ತು ಸೀವೇಜ್ಗಳನ್ನು ಡಿಸ್ಪೋಸ್ ಮಾಡಿದಾಗ, ಸೊ ಅದರಲ್ಲಿ ಹಾರ್ಮ್ಫುಲ್ ಬ್ಯಾಕ್ಟೀರಿಯಾಗಳು ಒಂದು, ಅದೇ ರೀತಿ ಬೇರೆ ಬೇರೆ ವೇಸ್ಟ್ಗಳು ಸೇರಿಕೊಂಡು ನದಿ ನೀರು ಕಲ್ಮಶಗೊಳ್ಳುತ್ತೆ. When this water seeps into the groundwater, water dissolves many minerals and salts present in the earth's layer. This water seeps into the ground. ಭೂಮಿಗೆ ಹೀರ್ಕೊಂಡಾಗ, so this enters into the groundwater, and several minerals and salts are absorbed from the earth's crust. So several salts are added to the water. So this is the this is how a pure rainwater is contaminated by different impurities. So what are the types of impurities? So mainly we can classify as two types of impurities, that is one that is soluble in water and that is not soluble in water. ನೀರಿನಲ್ಲಿ ಕರಗುವಂತ ಇಂಪ್ಯೂರಿಟೀಸು, ನೀರಿನಲ್ಲಿ ಕರಗದೇ ಇರುವಂತ ಇಂಪ್ಯೂರಿಟೀಸ್ ಅಂತ ನಾವು ಅನ್ಕೋಬಹುದು. So it is classified as three categories. First one is the suspended impurities, second one is the colloidal impurities, third one is the dissolved impurities. So suspended impurities, colloidal impurities and dissolved impurities. So suspended impurities, as the name indicates, suspended impurities are the impurities that are not soluble in water and they remain as particles dispersed in water. So ಈ ಸಸ್ಪೆಂಡೆಡ್ ಇಂಪ್ಯೂರಿಟೀಸ್ ಏನಿದೆ ಇದು ನೀರಿನಲ್ಲಿ ಕರಗೋದಿಲ್ಲ. ಸೊ ಅದು ಸಣ್ಣ ಸಣ್ಣ ಕಣಗಳಾಗಿ ನೀರಿನಲ್ಲಿ ಹರಡ್ಕೊಂಡಿರುತ್ತೆ, ಡಿಸ್ಪರ್ಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ದೇ ಆರ್ ಲಾರ್ಜ್ ಎನಫ್ ಟು ಬಿ ರಿಮೂವ್ಡ್ ಬೈ ಫಿಲ್ಟ್ರೇಷನ್. ಸೊ ಫಿಲ್ಟ್ರೇಷನ್ ಇಂದ ಅದನ್ನು ನಾವು ತೆಗಿಬಹುದು. ಸೊ ಇಟ್ ಈಸ್ ಆರ್ಗ್ಯಾನಿಕ್ ಆರ್ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಇನ್ ನೇಚರ್. ಇಟ್ ಮೇಕ್ಸ್ ದ ವಾಟರ್ ಅನ್ಅಟ್ರಾಕ್ಟಿವ್ ಅಂಡ್ ಅಫೆಕ್ಟ್ಸ್ ದ ಟ್ರೀಟ್ಮೆಂಟ್ ಪ್ಲಾಂಟ್ಸ್. ಸಿನ್ಸ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಡಿಸ್ಪರ್ಸ್ಡ್ ಇನ್ ದ ವಾಟರ್, so they makes the water unattractive. So muddy like appearance. So ಅಲ್ಲಿ ಕಣಗಳು ಎಲ್ಲ ಕಡೆ ಹರಡ್ಕೊಂಡಿರೋದ್ರಿಂದ ಸೊ ನೀರು ನಮಗೆ ಅಷ್ಟು ಆಕರ್ಷಕವಾಗಿ ಕಾಣೋದಿಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ಇಟ್ ಬಿಕಮ್ಸ್ ಅನ್ಅಟ್ರಾಕ್ಟಿವ್ ಅಂಡ್ ಅಫೆಕ್ಟ್ಸ್ ದ ಟ್ರೀಟ್ಮೆಂಟ್ ಪ್ಲಾಂಟ್ಸ್. ಸಸ್ಪೆಂಡೆಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೇ ಕಂಟೈನ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ, ಆಲ್ಗೆ, ಫಂಗೈ, ಪ್ರೋಟೋಜೋವಾ, ಕ್ಲೇ ಅಂಡ್ ಸಿಲ್ಟ್. ಸೊ ಸಸ್ಪೆಂಡೆಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ನಲ್ಲಿ ಇಂಪ್ಯೂರಿಟೀಸ್ನಲ್ಲಿ ಏನೇನೆಲ್ಲ ಇರ್ಬೋದು? ಸೊ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ಇರುತ್ತೆ. ಸೊ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ಅಲ್ಲಿ ಎರಡು ಥರ ಹೇಳ್ಬೋದು. ಒಂದು ಪ್ಯಾಥೋಜೆನಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ, ರೋಗಕಾರಕ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗೆಯೇ ನಾನ್ ಪ್ಯಾಥೋಜೆನಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ. ಸೊ ಪ್ಯಾಥೋಜೆನಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಅಂದರೆ ರೋಗವನ್ನು ತರುವಂಥ ಬ್ಯಾಕ್ಟೀರಿಯಾ. ದೋಸ್ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ವಿಚ್ ಬ್ರಿಂಗ್ ಡಿಸೀಸಸ್ ಆರ್ ಕಾಲ್ಡ್ ದ ಪ್ಯಾಥೋಜೆನಿಕ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ. ಬಟ್ ಸಮ್ ಬ್ಯಾಕ್ಟೀರಿಯಾ ಆರ್ ಯೂಸ್ಫುಲ್ ಅಂಡ್ ದೇ ಆರ್ ನಾಟ್ harmful. Such bacteria are called non-pathogenic bacteria. So algae, fungi and protozoa. So algae ಅಂದ್ರೆ ನಾವು ಪಾಚಿ ಅಂತ ಕರಿತೀವಿ, fungi ಶಿಲೀಂಧ್ರ, protozoas, these cause odor and turbidity to the water. So they bring, odor means smell, so turbidity means muddy appearance. So these brings water, the turbidity and odor to the water. Clay and silt cause turbidity. So clay means muddy particles, that is ಜೇಡಿ ಮಣ್ಣಿನ ತರದ ಪದಾರ್ಥಗಳು. ಸಿಲ್ಟ್ ಅಂದರೆ ಹುಳು ಮಣ್ಣು ಅಂತ ಕರಿತಿರಲ್ವಾ. So clay and silt cause turbidity. So muddy like appearance is formed due to the suspended impurities. So first type is the suspended impurities. Second type is the colloidal impurities. So these are the finely divided particles. These are very small in nature and these are also dispersed in water. So ನೀರಿನಲ್ಲಿ ಇದು ಸಹಿತ ಎಲ್ಲ ಕಡೆ ಹರಡ್ಕೊಂಡಿರುತ್ತೆ. ಹಾಗೆ ಇದು ತುಂಬ ಸೂಕ್ಷ್ಮ ಪದಾರ್ಥಗಳು. They cannot be removed by ordinary filtration. So special treatment methods are required. Such chemical methods are required to remove the colloidal impurities. They are always in motion and they are electrically charged. So since they are electrically charged, the particles repel each other one another and they are always in motion. So colloidal particles are not visible to the naked eye. Their property is they impart color to the water. But these are associated with the organic matter and may be chief source of epidemics. So ಇದರ ಹತ್ರ ಆರ್ಗ್ಯಾನಿಕ್ ಮ್ಯಾಟರ್ಸ್ಗಳು ಇರೋದ್ರಿಂದ ಸೊ ಕಾಯಿಲೆಗಳು ಬರುವಂಥ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ದೇ ಆರ್ ನಾಟ್ ಈಸಿಲಿ ರಿಮೂವಬಲ್. Chemical action is needed. So chemical action is needed to remove the colloidal particles. Dissolved particles, ನೀರಿನಲ್ಲಿ ಕರಗಿರುವಂಥ ಪದಾರ್ಥಗಳು. So dissolved impurities are the impurities that are dissolved in the water. So solids, liquids and gases are dissolved in the natural water. So ಸಾಲಿಡ್ಸು ಕರಗಬಹುದು, ಘನ ಪದಾರ್ಥಗಳು ಮತ್ತು ದ್ರವ ಪದಾರ್ಥಗಳು ಮತ್ತು ಅನಿಲ ಪದಾರ್ಥಗಳು ಎಲ್ಲವೂ ಸಹಿತ ನೀರಿನಲ್ಲಿ ಕರಗಿರಬಹುದು. ಸೊ ಯಾವ್ದಾದಿರ್ಬೋದು ಹಾಗಾದರೆ ನೋಡೋಣ. ಡಿಸಾಲ್ವ್ಡ್ ಇಂಪ್ಯೂರಿಟೀಸ್ ಮೇ ಕಂಟೈನ್ಸ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್, metals and gases etc. So metals ಇರ್ಬೋದು, gases ಇರ್ಬೋದು, organic compounds ಇರ್ಬೋದು. So some carbonate and bicarbonate salts ಇವು ನೀರಿನಲ್ಲಿ ಕರಗಿದ್ರೆ salts in the form of carbonates and bicarbonates causes hardness. hardness ಅಂದರೆ ಗಡಸು ನೀರು ಅಂತ ಕರಿತೀವಲ್ಲ ಅದು. ಸೊ ಕಾರ್ಬೋನೇಟ್ಸ್ ಮತ್ತು ಬೈಕಾರ್ಬೋನೇಟ್ ಸಾಲ್ಟ್ಸ್ ನೀರಲ್ಲಿದ್ದರೆ ನೀರಿಗೆ ಗಡಸುತನ ಬರುತ್ತೆ, ಹಾರ್ಡ್ನೆಸ್ ಬರುತ್ತೆ. ಸೊ ಇಫ್ ಮೆಟಲ್ಸ್ ಅಂಡ್ ಕಾಂಪೌಂಡ್ಸ್, ಇಫ್ ಐರನ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ವಾಟರ್, ಇಟ್ ಕಾಸಸ್ corrosion and imparts red color. So iron imparts red color to the water. If magnesium is present in the water, it imparts brown color to the water. If lead and arsenic are present in the water, they are highly toxic or poisonous, so it should not be present in the water. So some metals and compounds like these forms may exist in the water in the dissolved form. Next, gases. So gases such as oxygen, chlorine, ammonia, hydrogen sulfide may exist in the water. So oxygen, higher amount of oxygen may causes corrosion of the metal. Chlorine and ammonia brings bad taste and odor. So these are the dissolved impurities, the impurities which are dissolved in the water. So there are three types: suspended impurities, colloidal impurities and the dissolved impurities. So now let us see analysis of water. What is the analysis of water? Analysis means ವಿಶ್ಲೇಷಣೆ, ನೀರನ್ನು ಯಾಕೆ ವಿಶ್ಲೇಷಣೆ ಮಾಡಬೇಕು. ಸೊ ಅನಾಲಿಸಿಸ್ ಆಫ್ ವಾಟರ್, ಎಕ್ಸಾಮಿನೇಷನ್ ಆಫ್ ವಾಟರ್. ಸೊ what is the purpose of examining the water? So we are studying the quality aspect of the water. So in order to study the quality aspects, several physical, chemical and bacteriological examinations are done on the water. So let us see what is analysis of water and why analysis of water has to be carried out. So analysis means the process of testing the water to ensure quality and safe drinking water is called the analysis of water. So water is tested for physical characteristics such as temperature, color, etc. Chemical characteristics such as the chemical ingredients that are present in the water such as chloride, fluoride, etc. Bacteriological characteristics for the presence of bacteria. So in order to ascertain a safe drinking water to the public, the parameters in the water are checked. So the process of testing the water is called the analysis of water. So what is the purpose of water analysis? Why we have to check the water? Why we have to check the water? So water is to analyze the physical, chemical and biological characteristics of the water. So ನೀರಿನಲ್ಲಿ ಇರುವಂಥ ಅದರ ಕೆಮಿಕಲ್ಸ್ಗಳಿರ್ಬೋದು, ಮೆಟಲ್ಸ್ಗಳಿರ್ಬೋದು, ಮಿನರಲ್ಸ್ಗಳಿರ್ಬೋದು, ಅದರ ಪ್ರಮಾಣ ಎಷ್ಟಿದೆ, ಹಾಗೆಯೇ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ಗಳು ಅದರಲ್ಲಿ ನೀರಿನಲ್ಲಿ ಇದೆಯಾ, ಹಾಗೆಯೇ ನೀರಿನ ಟೆಂಪರೇಚರು, ಕಲರು ಯಾವ ರೀತಿ ಇದೆ, ಇದನ್ನೆಲ್ಲ ನಾವು ಅನಲೈಸ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಫಿಸಿಕಲ್ ಅನಾಲಿಸಿಸ್ ಆಫ್ ವಾಟರ್ನ ನಾವು ಮಾಡ್ತೀವಿ. ಟು ಡಿಟರ್ಮೈನ್ ದ ಡಿಗ್ರಿ ಆಫ್ ಪೊಲ್ಯೂಷನ್ ಆಫ್ ದಿ ವಾಟರ್, ಹೌ ಮಚ್ ದ ವಾಟರ್ ಈಸ್ ಪೊಲ್ಯೂಟೆಡ್. ಸೊ pollution due to various sources. So how much degree of pollution of water it is subjected to, that is checked by water analysis. And also that determine the level of organic and inorganic impurities in the water, we conduct the water analysis to ascertain the degree of purification needed. So in the treatment plants there are several units and each unit has to be checked whether the degree of purification has been achieved at that step. So that's why the analysis is done in the purification plants. To ascertain the suitability of water for a specific purpose, to check whether this water is suitable for the drinking purpose, or to check whether this water is suitable for the swimming pools, etc. For a specific purpose, this water is suitable or not. We check by water analysis. So sampling of water. So what is sampling of water? So in order to assess the water quality, we have to carefully collect the samples, and method of collecting the samples is called the sampling. ಸೊ ನೀರಿನ ಮಾದರಿಗಳನ್ನು ನಾವು ಪರೀಕ್ಷೆ ಮಾಡೋದಕ್ಕೋಸ್ಕರ ನಾವು ಏನು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಅದಕ್ಕೆ ನಾವು ಸ್ಯಾಂಪ್ಲಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸ್ಯಾಂಪಲ್ಸ್ ನಾವು ಏನು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀವಿ ಅದು ಒರಿಜಿನಲ್ ಸೋರ್ಸನ್ನು ಪ್ರತಿನಿಧಿಸುವ ರೀತಿ ಇರಬೇಕು. ಸ್ಯಾಂಪಲ್ ಶುಡ್ ಬಿ ದ ರೆಪ್ರೆಸೆಂಟೇಟಿವ್ಸ್ ಆಫ್ ದಿ ವಾಟರ್ ಸೋರ್ಸ್. So how to collect the samples? So collection of the samples depends upon the purpose of the examination. If the sample is to be collected for the physical examination, such as color, odor, etc., they may be collected in a container. If the sample is to be collected for chemical analysis, the bottles with the stoppers are to be used. And if the analysis is for the bacterial purpose, special care has to be taken, and the bottle should be properly sterilized, and it should not contain any other ingredients. So very carefully we have to collect the samples. So after collection, the bottles have to be properly labeled, indicating the location where it is collected, time of sampling, date of the sampling, bottle name, bottle number. So all these things have to be mentioned specifically in a label and tagged to the bottle. If the water is to be collected from a tap water, so the collection of the water also depends upon the source of water from where we are collecting the sample. If the sample is to be collected from a tap water, then we have to allow the tap water to run for several minutes so that stagnant water does not disturb the sample. So after allowing the water to flow for a certain time, then only the tap water is collected. If the water is to be collected from rivers or surface sources, we have to collect the samples from 40 to 50 centimeter below the surface of the water. So if the surface is collected from a surface source, we have to collect 40 to 50 centimeter below the surface of the water. If the sample is to be collected from an underground source or a tube well, we have to pump the water sufficiently for a certain time, and thereafter only the water has to be collected. This is because we don't want to collect the topmost upper stagnant water, so that's why we allow the water to flow for a few minutes and then only we collect the samples. Extra care is to be taken for bacterial analysis of the sample. So special care, we had to sterilize the bottle by using the H2SO4 and potassium chromate solutions, and then it is washed with the distilled water, and after proper sterilization only the bacterial examination sample has to be collected. So let us see. So there are three types of examination of water we have already discussed. First one is the physical examination of water. Second one is the chemical examination of the water. Third one is the bacterial examination of the water. So let us see one by one. What is the physical examination of water? The physical examination of water includes temperature, color, turbidity, taste, and odor. So these are the physical examinations, the ಭೌತಿಕ ವಿಶ್ಲೇಷಣೆ ಅಂತ ಕರಿತೀವಿ. So the physical examination of water include temperature, color, turbidity, taste, and odor. So let us see one by one what is the significance of conducting these tests. So first one is the temperature. So why we have to check the temperature of the water? Anyhow, we cannot control the temperature of the water. If the temperature is high, we cannot dilute the water because the quantity of water is more. So there is we cannot control the temperature. But then why we have to check the temperature? So temperature is sometimes affects the ಸಾಲ್ಯುಬಿಲಿಟಿ ಆಫ್ ದಿ ಡಿಫರೆಂಟ್ ಮೆಟೀರಿಯಲ್ಸ್ ಇನ್ ವಾಟರ್. ದಟ್ ಈಸ್, ನೀರಿನಲ್ಲಿ ಕೆಲವೊಂದು ಪದಾರ್ಥಗಳು ಕರಗುವಿಕೆಗೆ ಟೆಂಪರೇಚರ್ ಏನಾಗುತ್ತೆ, ಅಫೆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಇಫ್ ದ ಟೆಂಪರೇಚರ್ ಈಸ್ ಮೋರ್, ಸಾಲ್ಯುಬಿಲಿಟಿ ವಿಲ್ ಬಿ ಮೋರ್. ಸೊ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಇತ್ತು ಅಂದರೆ ಕೆಲವೊಂದು ಮೆಟೀರಿಯಲ್ಸ್ ನೀರಿನಲ್ಲಿ ಕರಗುವಂಥ ವೇಗನೂ ಸಹಿತ ಜಾಸ್ತಿ ಆಗ್ಬೋದು. ಅದೇ ರೀತಿ ಇಂಡಸ್ಟ್ರಿಯಲ್ ವೇಸ್ಟ್ಗಳು ಡಿಸ್ಪೋಸ್ ಮಾಡಿದ್ರೆ, ಸೊ ನೀರಿನಲ್ಲಿ ಇಂಡಸ್ಟ್ರಿಯಲ್ ವೇಸ್ಟ್ಗಳು ಡಿಸ್ಪೋಸ್ ಆಗಿದ್ರೆ ಸೊ ಟೆಂಪರೇಚರ್ ವೇರಿ ಆಗುವಂಥ ಚಾನ್ಸಸ್ಸು ಇರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಇಟ್ ಮೇ ಇಂಡಿಕೇಟ್ ದಟ್ industrial wastes are disposed to the water. So how this temperature is measured? Temperature is measured by ordinary thermometers. By using the ordinary thermometer, we measure the temperature. Usually surface water is generally at the atmospheric temperature. So normal ಆಗಿ atmospheric temperature ಅಷ್ಟೇ surface water ಇರುತ್ತೆ, ಇಲ್ಲ ಸ್ವಲ್ಪ ಕಮ್ಮಿ ಇರಬಹುದು. So ground water may be or more or less than the atmospheric temperature. ಸೊ ಗ್ರೌಂಡ್ ವಾಟರ್ ಸ್ವಲ್ಪ ವೇರಿಯೇಷನ್ಸ್ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಟೆಂಪರೇಚರ್ಗಿಂತ ಜಾಸ್ತಿ ಅಥವಾ ಕಡಿಮೆ ಇರ್ಬೋದು. ಸೊ ವಾಟ್ ಈಸ್ ದ ಡಿಸೈರಬಲ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ ಟೆಂಪರೇಚರ್? ಸೊ ನೀರಿನ ಟೆಂಪರೇಚರ್ ಎಷ್ಟಿದ್ರೆ ಸರಿಯಾಗಿರುತ್ತೆ? ಸೊ ದ ವಾಟರ್ ಅಟ್ 10 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಈಸ್ ಹೈಲಿ ಡಿಸೈರಬಲ್. ಸೊ ವಾಟರ್ ಅಟ್ 10 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಈಸ್ ಹೈಲಿ ಡಿಸೈರಬಲ್, ವೈಲ್ ಟೆಂಪರೇಚರ್ ಅಬೌವ್ 25 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಅಬ್ಜೆಕ್ಷನಬಲ್. ಸೊ 10 ಡಿಗ್ರಿ ಇದ್ದರೆ ನೀರು ಅದು ಒಳ್ಳೆಯದು ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ 25 ಡಿಗ್ರಿಗಿಂತ ಜಾಸ್ತಿ ಇದ್ದರೆ ಇಟ್ ಈಸ್ ಅಬ್ಜೆಕ್ಷನಬಲ್. ನೆಕ್ಸ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಕಲರ್. ಸೊ ಕಲರ್ ಆಫ್ ದಿ ವಾಟರ್, ನೀರಿಗೆ ಕಲರ್ ಯಾತ್ರಿಂದ ಬರುತ್ತೆ? ಸೊ ಕಲರ್ ಆಫ್ ದಿ ವಾಟರ್ ಈಸ್ ಡ್ಯೂ ಟು ಆರ್ಗ್ಯಾನಿಕ್ ಮ್ಯಾಟರ್ ಇನ್ ದ ಕೊಲಾಯ್ಡಲ್ ಸೊಲ್ಯೂಷನ್ಸ್. ಸೊ ಆರ್ಗ್ಯಾನಿಕ್ ಮ್ಯಾಟರ್ ಸಾವಯವ ಪದಾರ್ಥಗಳಿಂದ ಬಂದಿರಬಹುದು. ಸೊ ಡಿಕೆ ವೆಜಿಟೇಬಲ್ಸ್, ಪ್ಲಾಂಟ್ಸ್, ಡಿಕೇಡ್ ಲೀವ್ಸ್, ಸೊ ಅಂಥವುಗಳಿಂದ ಬಂದಿರಬಹುದು. ಅದೇ ರೀತಿ ಡಿಸಾಲ್ವ್ಡ್ ಆರ್ಗ್ಯಾನಿಕ್ ಮ್ಯಾಟರ್ಸ್, ನೀರಿನಲ್ಲಿ ಕರಗಿರುವಂಥ ಆರ್ಗ್ಯಾನಿಕ್ ಮ್ಯಾಟರ್ಸ್ಗಳಿಂದ ಬಂದಿರಬಹುದು. ಸಮ್ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಮೆಟಲ್ಸ್ ಸಚ್ ಆಸ್ ಐರನ್ ಇರ್ಬೋದು, ಮ್ಯಾಂಗನೀಸ್ ಇರ್ಬೋದು. ಸೊ ಈ ಥರ ಮೆಟಲ್ಸ್ಗಳು ನೀರಿನಲ್ಲಿ ಕರಗಿರೋದ್ರಿಂದ ಅಂಥ ಮೆಟಲ್ಸ್ಗಳಿಂದ ನೀರಿಗೆ ಕಲರ್ ಬರ್ಬೋದು. ಆಲ್ಗೆ ಆ್ಯಂಡ್ ಆಕ್ವಾಟಿಕ್ ಪ್ಲಾಂಟ್ಸ್, ಪಾಚಿ ಮತ್ತು ಇತರೆ ನೀರಿನಲ್ಲಿ ವಾಸಿಸುವ ಸಸ್ಯಗಳಿಂದ ಸಹಿತ ನಮಗೆ ಕಲರ್ ಬರಬಹುದು ನೀರಿಗೆ. ಸೊ ಆರ್ಗ್ಯಾನಿಕ್ ಮ್ಯಾಟರ್ಸ್, dissolved organic matters, inorganic metals, algae and aquatic plants imparts color to the water. So what is the significance of color in the water? So color, how do we measure the color? So color is measured with visual examination of sample with platinum cobalt standards. So 1 ಯೂನಿಟ್ ಆಫ್ ಕಲರ್ ಅಂತ ನಾವು ಯಾವುದನ್ನು ಹೇಳ್ತೀವಿ ಅಂದರೆ, 1 ಲೀಟ್ರು ನೀರು ತಗೊಂಡ್ಬಿಟ್ಟು ಆ 1 ಲೀಟರ್ ವಾಟರ್ಗೆ 1 mg ಅಷ್ಟು, 1 ಮಿಲಿಗ್ರಾಮ್ ಅಷ್ಟು ಪ್ಲಾಟಿನಮ್ ಕೊಬಾಲ್ಟನ್ನು ಹಾಕಿದ್ರೆ ಸೊ ಏನು ಕಲರ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೋ ದಟ್ ಕಲರ್ಗೆ ನಾವು 1 ಯೂನಿಟ್ ಆಫ್ ಕಲರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ 1 ಲೀಟರ್ ಆಫ್ ವಾಟರ್ಗೆ 1 ಮಿಲಿಗ್ರಾಮ್ ಅಷ್ಟು ಪ್ಲಾಟಿನಮ್ ಕೊಬಾಲ್ಟ್ ಹಾಕಿದ್ರೆ ಏನು ಕಲರ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೋ that color is called the standard unit of the color. So how do we compare, how do we examine that color of our sample? So this is done by visual examinations. So what we do is, in the laboratory we prepare different units of the color. That is, in a one bottle we 1 liter of water is taken and 1 mg of platinum cobalt is placed, and this becomes the 1 unit of color. In the another bottle we add 2 mg of the platinum cobalt in 1 liter of the water, and the color produced is observed, and that is the 2 units of color. Similarly, several such tubes are prepared and kept in the laboratory. If a sample of water is to be examined for color, that sample is brought to the laboratory, and the color of this sample is compared with the color of the already prepared samples in the laboratory, and the matching color indicates the unit of color. So that's how we determine the color of the sample. So ಈ ಥರ ಬೇರೆ ಬೇರೆ ರೀತಿ ಪ್ಲಾಟಿನಮ್ ಕೊಬಾಲ್ಟ್ ಹಾಕಿರುವಂಥ ಸ್ಯಾಂಪಲ್ಸ್ಗಳನ್ನ ನಾವು ಲ್ಯಾಬೊರೇಟರಿನಲ್ಲಿ ರೆಡಿ ಮಾಡಿ ಇಟ್ಕೊಂಡಿರ್ತೀವಿ. ಸೊ 1 ಲೀಟರ್ಗೆ 1 mg ಹಾಕಿದ್ರೆ ಅದು 1 ಯೂನಿಟ್ ಆಫ್ ಕಲರ್ ಆಗುತ್ತೆ. 2 mg ಅಷ್ಟು ಹಾಕಿದರೆ ಅದು 2 ಯೂನಿಟ್ ಆಫ್ ಕಲರ್ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ 3 mg ಹಾಕಿದರೆ 3 ಲೀಟರ್ ಅಷ್ಟು ಆಗುತ್ತೆ, 3 ಯೂನಿಟ್ ಆಫ್ ಕಲರ್ ಆಗುತ್ತೆ. ಈ ಥರ ವಿ ಪ್ರಿಪೇರ್ ಡಿಫ್ರೆಂಟ್ ಟ್ಯೂಬ್ಸ್ ಆ್ಯಂಡ್ ವಿ ಕೆಪ್ಟ್ ಇನ್ ದ ಲ್ಯಾಬೊರೇಟ್ರಿ. ಈಗ ನಾವು ಯಾವುದೋ ಒಂದು ಸ್ಯಾಂಪಲ್ನ ಟೆಸ್ಟ್ ಮಾಡಬೇಕಾಗಿರುತ್ತೆ ಅಂದರೆ ಆ ಸ್ಯಾಂಪಲ್ನ ತೊಗೊಂಬರ್ತೀವಿ, ಅದನ್ನು ನಾವು ನಮ್ಮ ಕಣ್ಣಿನ ಮೂಲಕನೇ ವಿಜುವಲ್ ಎಕ್ಸಾಮಿನೇಷನಿಂದ ಸೊ ಅದನ್ನು ವಿ ಕಂಪೇರ್ ಇಟ್, ಇದ್ರ ಕಲರ್ನ ಆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಟ್ಯೂಬ್ಸ್ಗಳ ಜೊತೆ ಇರುವಂಥ ಕಲರ್ನ ನಾವು ಕಂಪೇರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಯಾವ ಕಲರ್ಗೆ ಮ್ಯಾಚ್ ಆಗುತ್ತೋ ದಟ್ ಈಸ್ ದ ಯೂನಿಟ್ ಆಫ್ ದಿ ಕಲರ್, ದಟ್ ಈಸ್ ದ ನಮ್ಮ ಸ್ಯಾಂಪಲ್ದು ಕಲರು ಅಷ್ಟಿದೆ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಸೊ ಕಲರ್ ಈಸ್ ವಿಜುವಲಿ ಎಕ್ಸಾಮೈನ್ಡ್. ಸೊ ದೇರ್ ಈಸ್ ಅನದರ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಟು ಮೆಜರ್ ದ ಕಲರ್. ಕಲರ್ನ ಮೆಜರ್ ಮಾಡೋದಕ್ಕೆ ದೇರ್ ಈಸ್ ಎ ಪ್ರಿಸೈಸ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಕಾಲ್ಡ್ ಟಿಂಟೋಮೀಟರ್. ಟಿಂಟೋಮೀಟರ್ ಅಂತ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಇದೆ, ಅದರಿಂದ ನಾವು ಕಲರ್ನ ಮೆಜರ್ ಮಾಡ್ಬೋದು. ಸೊ ದಿಸ್ ಟಿಂಟೋಮೀಟರ್, this is the tintometer. This tintometer has an eyepiece, so that is called the eyepiece. So that eyepiece has 2 holes. This eyepiece has the 2 holes. So one is for the sample to be tested and another is for the standard colored slices. As we have already discussed, standard colored slices are prepared and kept in the laboratory. So another sample is the sample to be tested. So from the eyepiece we compare, so there is a hole in the eyepiece, so one hole is reserved for the sample to be tested and another hole is for the for the standard colored specimens. So from the eyepiece we observe the 2 samples and matching color is found, and that's how we calculate the color from the tintometer. So this is called the tintometer, which is used to measure the color. So acceptable limits of color. So what should be the maximum limit of color in the water? So for public supplies, the color on the cobalt scale, that is platinum cobalt scale, should not exceed 20 and preferably less than 10. So it should not exceed 20 and preferably less than 10. Recent standards, that is Indian standards 10,500 2012 has revised this standard, and the acceptable limit is 5 on the Hazen units and permissible limit is 15 on the Hazen unit. The maximum allowed color in the water is 5 units on the Hazen units and the permissible unit is 15 on the Hazen units. So that's the significance of color and how measurement of the color in the water. Next comes turbidity. So turbidity. So what is turbidity? You can observe the figure. The left beaker is fully clear, that does not contain any suspended or impurities. So second one is like it is of like some cloudy appearance. Third one, there is some muddy appearance. Fourth one, still more muddy appearance. Fifth one is having high turbidity. So first one is the clear water, which is having low turbidity. Last one is the murky water, that is muddy water with high turbidity. So from this, can you guess what is turbidity? So turbidity is the muddy appearance in the water is due to clay and other particles which obstructs the path of the light is called the turbidity of water. So clear water does not obstruct the path of the light. So clear water ಏನಿರುತ್ತೆ ಅದು ಬೆಳಕನ್ನು ತಡೆಯೋದಿಲ್ಲ. ಸೊ ಒಂದು ಕಡೆಯಿಂದ ಇನ್ನೊಂದು ಕಡೆಗೆ ಬೆಳಕು ಪಾಸ್ ಆಗುತ್ತೆ. ಆದರೆ ಮಡ್ಡಿ ವಾಟರಲ್ಲಿ ನೀವು ಈ ಕಡೆಯಿಂದ ಬೆಳಕು ಬಿಟ್ಟರೆ ಸೊ ಅದು ಪಾಸ್ ಆಗೋದಿಲ್ಲ. ಸೊ ಮಡ್ಡಿ ವಾಟರ್ ಏನಾಗುತ್ತೆ, ಕಲರ್ನ ಬೆಳಕನ್ನು ತಡೆಯುತ್ತೆ. ಸೊ the muddy or cloudy appearance of clay or other particles which obstructs the path of the light is called the turbidity of the water. So turbidity is caused due to the presence of suspended and colloidal matters in the water. So we have already seen what is suspended and colloidal particles. So these suspended particles are in a state of suspension, that is they are scattered in the water, and these particles imparts turbidity in the water. ಸೊ ಟರ್ಬಿಡಿಟಿ ಈ ಸಸ್ಪೆಂಡೆಡ್ ಮತ್ತು ಕೊಲಾಯ್ಡಲ್ ಪಾರ್ಟಿಕಲ್ಸ್ಗಳಿಂದ ಬರುತ್ತೆ. ಸೊ turbidity is the measure of resistance of water to the passage of light through it. So it obstructs the light of the path of the light. So if the water is with zero turbidity, it is crystal clear and no resistance is offered for the passage of the light. If the water is having high turbidity, it obstructs the path of the light and it is having high turbidity. So how this turbidity is measured? So turbidity is measured in several units. That is, first one is the NTU, that is nephelometric turbidity units. So if the instrument it is measured in nephelometric instruments, it is in NTU. Second one is the ppm, that is parts per million. Third one is milligram per liter. So it is expressed in these units. So how do you say that this water is having a turbidity of 1? So as we have observed in the color measurement of the color, similarly in the turbidity also, so we may say that this water is turbid when of 1 unit when 1 milligram of finely divided silica, 1 mg of finely divided silica, that is sand, fine sand, is dissolved in 1 liter of water. The turbidity produced, that is the muddy appearance produced, is called 1 unit. So 1 mg of silica, if you place 1 mg of silica in 1 liter of the water, the muddy appearance or the turbidity observed is called the 1 unit. So how do we measure the turbidity of water? So turbidity of water is measured by several methods. First one is the turbidity rod or tape. Second one is the Jackson turbidity meter. Third one is the Bailey's turbidity meter. So how do we measure the turbidity? Let us see one by one. So as we have already discussed, turbidity offers resistance to the path of light. So there are these instruments are used to measure the turbidity. So first one is the turbidity rod. So this turbidity rod is used to measure the turbidity in the field. So it is a field measurement. So as indicated in the figure, it indicates the lower part consists of a graduated aluminum rod. That is, it is an aluminum rod on which the graduations, that is the measurements, are marked on the aluminum rod. On the lowermost part there is a platinum needle. You can observe there is a platinum needle, and in the uppermost part there is a graduated tape. There is non-stretchable graduated tape which is used to insert the turbidity rod into the water, and an eye position is marked on the top. You can observe there is a hole where it is marked as eye position. So this is the turbidity rod. So turbidity rod is having a graduated aluminum rod at the bottom with the graduations. At the bottommost there is a hole with the platinum needle. Graduated tape is placed with the non-stretchable graduated tape is there at the top. The position of the eye is marked at the top. So how do we measure the turbidity of water using this turbidity rod? So what we do here is, if we want to measure the turbidity of water or a sample in the like river, streams, etc. So what we do is, first we lower this instrument into the water. So the bottommost part, that is the graduated aluminum rod, is lowered into the water. So this portion is lowered, and from the top there is a marking eye position. From this eye position, the needle, that is the platinum needle at the bottom, is observed, whether it is visible or not. So ಕೆಳಗಡೆ ಇರುವಂತ ಪ್ಲಾಟಿನಮ್ ನೀಡಲ್ನ ನಾವು ಮೇಲೆ ಇರುವಂತ ಕಣ್ಣು ಈ ಜಾಗದಲ್ಲಿ ನಾವು ಕಣ್ಣಿನಿಂದ ನೋಡಬೇಕಂತ ಮಾರ್ಕ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಅಲ್ಲಿಂದ ನಾವು ಮೇಲಿಂದ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ ಆ ಪ್ಲಾಟಿನಮ್ ನೀಡಲು ಕಾಣ್ತಾ ಇದೆಯಾ ಅಥವಾ ಇಲ್ಲ ಅಂತ. So if the water is clear, we can observe the platinum needle. If there is turbidity, so what actually happens is, when you lower the turbidity at a certain point, this platinum needle is not visible. So at that point is noted, and the to how much depth this rod is inserted is measured from the graduated aluminum rod. So that indicates the turbidity of the water. So what we do here, we first lower this instrument into the water. From the eye position, we observe the platinum needle at the bottom. If it is, we lower the instrument up to the point where this platinum needle is completely invisible. Why this happens? Because the muddy appearance of the water obstructs the path of the light, and this needle will not be visible. So at that point, we measure the readings in the graduated aluminum rod. So this is how we measure the turbidity in the field. So next, turbidity meter. So in order to measure the turbidity in the laboratory, we use the instrument called turbidity meter. Jackson turbidity meter can be used to measure the turbidities in the range of 25 to 1000 mg per liter. So this is the Jackson turbidity meter, which is used to measure the turbidity in the laboratories. So you can observe the parts of a Jackson turbidity meter. So it has a graduated glass tube at the top. So it is placed in a metal container. At the bottom there is a metal stand and a standard candle is placed. So these are the parts of a Jackson turbidity meter. So there is a candle at the bottom, there is a graduated glass tube at the top. So what we do here, there is a candle with flame at the bottom. So the graduated glass tube is placed in the metal container at the top. So we place the graduated glass tube in the metal container at the top position. So we go on pouring the water into the glass tube and observe the flame below from the top eye position. So we pour the water to the graduated glass tube and observe the flame from the top. If it is visible, we pour some more water until the flame disappears from the view. So why the flame has disappeared? Due to the obstruction to the path, that is the muddy appearance make the candle invisible. So this measurement is noted, and this indicates the turbidity of the water. So this is the basic principle behind the Jackson's turbidity meter. In this Jackson turbidity meter, so a candle or a flame is at the bottom. We pour water into a graduated glass tube until this flame is not visible. So this indicates the turbidity of the water. So there are some instruments such as turbidity meters. First one we have seen, Jackson turbidity meter. Like that, there are several other instruments like Bailey's turbidity meter. So what is the unit of turbidity? So on nephelometric turbidity units, so it is measured in NTU units, that is nephelometric turbidity units. So the acceptable limit of turbidity is 1 NTU and the permissible limit is 5 NTU of turbidity. So in this class, so taste and odor. So taste and odor. So water, we measure the taste and odor in the water, but why we have to, what is the significance of taste and odor in the water? The taste and odor in the water is due to the presence of dead or living microorganisms. So the microorganisms imparts taste and odor to the water. Some of the gases such as hydrogen sulfide, hydrogen sulfide if present in the water gives a very bad smell and very bad taste to the water. And carbon dioxide also imparts very bad taste to the water. So these dissolved gases imparts color, taste and odor to the water. Some of the organic matters, minerals and substances also imparts taste and odor to the water. So according to the Indian standards, the how much taste and odor is to be there. So it specifies that unobjectionable amount of taste and odor is permissible. So acceptable values for our nose and other we can that is agreeable amount of taste and odor are permissible. So what happens if there is a the effects of odor and taste? The water having bad smell and odor is objectionable and should not be supplied to the public. So this is about the taste and odor. So in this session we have learnt about the various impurities in water and various physical examination that are conducted on the water. So what are the physical examination that are conducted on the water? Color, pH, turbidity, etc. These are the conducted on the water. So let us solve some multiple choice questions. So what is suspended impurity? You have studied what is suspended impurity. So suspended impurities should be present or should not be present in water. Why it should not be present in water? So suspended impurities should not be present in water because it causes muddy appearance, it is aesthetically displeasing, absorption sites for biological agents, all the above. So suspended impurities ನೀರಿನಲ್ಲಿ ಇರಬೇಕೋ ಬೇಡವೋ, ಯಾತಕ್ಕೋಸ್ಕರ ಇರಬಾರ್ದು? ಸೊ ಫಸ್ಟ್ ಇಟ್ ಕಾಸಸ್ ಮಡ್ಡಿ ಅಪಿಯರೆನ್ಸ್. ಇಸ್ ಇಟ್ ಟ್ರೂ? ಸಸ್ಪೆಂಡೆಡ್ ಪಾರ್ಟಿಕಲ್ಸು ಮಡ್ಡಿ ಅಪಿಯರೆನ್ಸ್ನ ಅಥವಾ ಮಣ್ಣು ಥರ ಅಪಿಯರೆನ್ಸನ್ನು ಪ್ರೊವೈಡ್ ಮಾಡುತ್ತಾ? ಎರಡನೇದು ಆಸ್ಥೆಟಿಕಲಿ ಡಿಸ್ಪ್ಲೀಸಿಂಗ್, ಅಂದರೆ ಅನ್ಅಟ್ರಾಕ್ಟಿವ್ ಅಪಿಯರೆನ್ಸು ನೀರಿಗೆ ಬರುತ್ತಾ ಸಸ್ಪೆಂಡೆಡ್ ಇಂಪ್ಯೂರಿಟೀಸಿಂದ? ಸೊ ದೀಸ್ ಆರ್ ದ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಸೈಟ್ಸ್ ಫಾರ್ ದ ಬಯೋಲಾಜಿಕಲ್ ಏಜೆಂಟ್ಸ್. ಸೊ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ಮತ್ತು ಅದರ್ ಆರ್ಗ್ಯಾನಿಸಮ್ಸು ಅಲ್ಲಿ ವಾಸ ಮಾಡುವಂಥ ಅವಕಾಶಗಳು ಇದೆಯಾ? ಆಲ್ ದ ಅಬೋವ್. ಸೊ ವಿಚ್ ಆನ್ಸರ್ ಡು ಯು ಥಿಂಕ್ ಇಟ್ ಈಸ್ ಟ್ರೂ? ಸಸ್ಪೆಂಡೆಡ್ ಇಂಪ್ಯೂರಿಟೀಸು ಯಾವ ಕಾರಣದಿಂದ ನೀರಿನಲ್ಲಿ ಇರಬಾರದು? ಸೊ ವಾಟ್ ಈಸ್ ದ ಆನ್ಸರ್? ಸೊ ದ ಆನ್ಸರ್ ಈಸ್ ಡಿ. ಸೊ ಯಾತಕ್ಕೋಸ್ಕರ ಡಿ? ಸಸ್ಪೆಂಡೆಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇದ್ರೆ ಸೊ ಇಟ್ ಕಾಸಸ್ ಮಡ್ಡಿ ಅಪಿಯರೆನ್ಸ್, so it is unattractive, and these are the absorption sites for the biological agents. So bacteria ಈ ಥರ ಬೇರೆ ಬೇರೆ ಮೈಕ್ರೋ ಆರ್ಗ್ಯಾನಿಸಮ್ಸ್ ಸಸ್ಪೆಂಡೆಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಹತ್ರ ಇರುವಂಥ ಇದರಿಂದ ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಅಬ್ಜೆಕ್ಷನಬಲ್. ಸೊ ಲೆಟ್ us move on to the second question. Tintometer. So tintometer is used to measure what? A. Color, B. Odor, C. Temperature, D. Turbidity. So tintometer is used to measure what? We have already studied this. What? So tintometer is used to measure color. So tintometer is used to measure the color by matching the colors of the standard slide and the sample. So by matching the color by visual examination, we measure the color of the sample to be tested. Water containing disease causing bacteria are called what? ಸೊ ರೋಗಕಾರಕ ಬ್ಯಾಕ್ಟೀರಿಯಾಗಳನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? ವಾಟರ್ ಕಂಟೈನಿಂಗ್ ಡಿಸೀಸ್ ಕಾಸಿಂಗ್ ಬ್ಯಾಕ್ಟೀರಿಯಾಸ್ ಆರ್ ಕಾಲ್ಡ್ ವಾಟ್? ಎ ಪೋರ್ಟಬಲ್ ವಾಟರ್, ಬಿ polluted water, C polluted water, C wholesome water, D contaminated water. So ಏನಂತ ಕರಿತೀವಿ? So water containing disease causing bacteria are called contaminated water. So we on to the next question. Identify turbidity measuring instruments. ಇವು ನಾಲ್ಕರಲ್ಲಿ ಟರ್ಬಿಡಿಟಿ ಮೆಜರಿಂಗ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಯಾವುದು? ಜಾಕ್ಸನ್ ಟರ್ಬಿಡ್ ಮೀಟರ್, ಟರ್ಬಿಡಿಟಿ ರಾಡ್, ಬೇಲೀಸ್ ಟರ್ಬಿಡ್ ಮೀಟರ್, all the above. As we know, the answer is D. That is, all these are used to measure the turbidity of the water. That is, Jackson turbidity meter, turbidity rod, and Bailey's turbid meter are used to measure the turbidity. Identify the physical tests on water. What are the physical tests that are conducted on the water? Color, odor, temperature, all the above. So the answer is D. All the above are the physical tests that are conducted in the water. So this is about this session. So in the next class we will take another session. Thank you.